So let's see one more example where Turing machine will act as a transducer in order to convert a number into its 2's complement. Here we are assuming that after converting a number into 2's complement, there is no overflow. What I mean is, if a given number, if a given number is n bits, then after converting into 2's complement, the resulting bits, the resulting number would be also in n bit. So under this assumption, we are doing this example. So there would be no overflow. Okay, so you are taken input string of n bits. The resultant string after 2's complement will also be n bits. So there will be no overflow. Okay, so no overflow is there. So under this assumption only we are considering this example. So let's see how we can build the logic for 2's complement. So to build a logic, let's take one example. I hope you know what is 2's complement, but again I will do it. So what is 2's complement is, this is an input string 0 1 1 1 0 0. So this is an input string. Now you have to convert into 2's complement. The traditional method says first you convert into 1's complement. Okay, so if you convert into 1's complement, then 0 become 1, 1 becomes 0, 1 becomes 0, 1 becomes 0, 0 become 1, 0 become 1, and 0 become 1. Okay, and after that you have to add 1. After that you have to add 1. Okay, so you have to add 1. Then when you add 1, whatever the result you get, that would be the 2's complement of a given input. So 1 1 is how much? 1 0, right? 1 plus 1 is how much? 1 0. So this 1 become carry and this become the result. So 0 and 1 become carry. Again 1 1 is how much? 1 0. So 0 and 1 carry, right? Now again 1 1 is 1 0. So 0 and 1 carry, right? Now 1 0 is how much? 1 0 is 1 itself. Okay, if you don't remember, then remember this. See, you take 0 0 0 1 1 0 1 1, then 0 0, when you add binary addition, this is not a normal addition, binary addition, then 0 0 is how much? 0 0 1 is 1, 1 0 is 1, and 1 1 is 1 1 is 1 0. Okay, so 0 will be the answer and 1 become carry. So 1 is your carry. So that is what we are exactly doing here. So 1 0 means 1 itself. Okay, then there is nothing is there. So 0 0. So 0 0 is 0. Again 0 0, which is 0. Then again 1. So 0 plus 1. So nothing is there means 0 plus 1 means 1. So this is your 2's complement of a number. Now what we have seen previously, that was a traditional method. We will see the shortcut also. So we will take the same input string. Okay, you remember this is called a least significant bit, and this is the most significant bit. Start from the least significant bit. Whenever you see any 0, okay, keep it as 0 itself. Whenever you see 0 again, keep it as 0 itself. Okay, again when you see the 0, keep it as 0 itself, and whenever you see the 1, okay, keep the first one as it is. Whenever you see the first one, keep the first one as it is. Then after that, after seeing first one, whatever you see after that, whatever the binary number you see, complement it, means do the 1's complement. 1 becomes 0, 1 becomes 0, 0 become 1. So after you visiting the first one, after that whatever binary number you see, do the 1's complement of it. So 1 becomes 0, 1 becomes 0, 0 become 1. So this also represent 2's complement. So this is a shortcut method. Okay, so we are going to use this logic only to build a Turing machine. Okay, so let's see how we can build a Turing machine with this similar logic. So what is our logic is, okay, our logic is go to LSB, that is the rightmost part, keep on seeing all zeros from RHS, means from right hand side. As long as we see 0, keep it as 0. As long as we see 0, keep it as 0. And whenever we come across first one, leave it as 1, and the remaining part we are going to make it as 1's complement. So this is the logic we are going to build, okay, for building a Turing machine. So the logic we are going to use for building a Turing machine. See, this is the input symbol we are given to the Turing machine, okay. So whenever you give any input symbol to the Turing machine, your read-write head will always point to the first symbol. Your read-write head will always point to the first symbol itself. So what we have to do is, we have to take this read-write head and have to point to the LSB, to the rightmost bit of the input string, okay, that is the LSB bit, okay. Then you have to, after pointing to the LSB bit, then you have to traverse this particular read-write head to the first one, okay. And after that you have to convert, whenever you find the first one, okay, keep that first one as it is, and after that whatever you see, you have to convert it, okay, that is, you have to perform a 1's complement of that particular one. So that is how the logic will work, okay. You take this read-write head, okay, traverse till the LSB bit, okay, rightmost bit. Then after pointing to this particular LSB bit, then after you start traversing all these zeros, okay, all these zeros, keep these zeros as it is, keep this 0 as, whenever you see the 0, keep this 0 as it is, okay. And whenever, unless and until you find the first one, okay, whenever you find the first one, keep that 1 as it is. Then after that, whatever symbol you see, okay, whatever symbol you see, for example, you have to do the 1's complement of that particular symbol. If you see 1, then you have to convert into 0. If you see 0, then you have to convert into 1. That is what the logic is. So first you have to design a Turing machine in such a way that you have to traverse till the LSB bit. So how can you design it? So take one initial state, Q node, okay. So we have to start from this position and we have to traverse till this first blank, right? So how can you do it? Whenever you see 0, we have to cross all the zeros and ones, right? So whenever you see 0, make it a 0 itself and move in right direction. This is left direction, this is right direction. Move in right direction, right? And whenever you see 1, keep it as 1 and move in right direction. So you will keep on traversing, your read-write head will keep on traversing unless and until you hit the blank. Now when you hit the blank, keep that blank as it is, okay. Now you are at this position, okay, you already crossed all the zeros and ones. Now turn left, after that you have to turn left, right? And now you are standing at Q1, right? After that, turning left, you will find this first symbol, okay. Turn left and move in the left direction and you will find the first symbol as 0. Now what you have to do, you have to, whenever you see any 0, when you start from LSB, whenever you see any 0, okay, whenever you see any 0, keep it as 0 itself and move in left direction, okay. You don't have to change it. I told you, unless until you find the first one, you have to keep that particular symbol as it is. So whenever you see 0, keep it as 0 itself. So whenever you see this 0, you will keep it 0 itself. Then you will move in left direction. Again you see 0, you will keep it as 0 itself, okay. Again when you see 0, you will keep it as 0 itself, okay. Now you are at this state, that is 1. Now whenever you see 1, keep it as 1, okay, because this is the first one, and move in left direction. Okay, so after that you will be in Q2 state, right? So you keep, whenever you see 1, you keep it as 1 itself and move in left direction. Now after that, whenever you see the first symbol, you have to start complementing, you have to do the ones complement. Now at Q2, whenever you see 1, okay, make it as 0. Whenever you see 1, make it as 0, okay, and move in left direction. Whenever you see 1, make it as 0 and move in left direction. Again you move in left direction. And whenever you see 0, make it as 1 and move in left direction. Whenever you see 0, make it as 1 and move in left direction. Now after moving in left direction, you will suddenly hit a blank. Now what you have to do, okay, so now after that, whenever you hit the blank, make it as blank, okay, and move, turn right or left, doesn't matter, okay. Now at this particular state Q3, it will halt. Are you getting it? So this is the halting state. This Q3 can be considered as a halting state because nothing is defined there, so it will stop there. So at the end of the procedure, we will stand at this Q3 state, and by that time we had already found a 2's complement of a binary number. Okay, so this is how the 2's complement of a binary number. Okay, so Turing machine will act as a transducer, and given an input as a binary number, it will take that input and it will convert into a 2's complement. That is why it is called a transducer. Okay, so hope you understood. See, one more thing, that this is not the only Turing machine for this particular input string. Okay, you can come up with many Turing machines depending upon your logic. So whatever the logic I had taken, for that I had built the Turing machine. Okay, there are many other Turing machines for same 2's complement number. You can build many other Turing machine. The only thing you have to take care is that that particular Turing machine, okay, should be act as a transducer for all the example, all the input string, whatever you're giving it. If it doesn't work for at least one string, okay, then you can reject that Turing machine. Okay, so better stick with the particular standard logic. Okay, so that is what I want to say.